Hey everyone, and welcome to RUBIN'S Mind Lab, where we break down the latest research into what it really means. Ever wonder why learning a new language can feel so tough, especially when it comes to sounding like a native speaker, even after years of practice? Well, this new study might have a clue, and it points to our motor control, not just our ears. Think about it. Most of us, even after living in another country and studying for years, still have that telltale accent. Scientists have wondered about this for ages. The common idea, and it makes a lot of sense, is that our first language, our native tongue, kind of messes with how we hear and then produce sounds in a new language. It is like our first language sets up these mental categories for sounds, and it is hard to break out of them for a second language. But what if the problem isn't just about hearing, but about doing? What if it is about the physical movements our mouths make to produce those sounds? That is exactly what this fascinating study set out to explore. The researchers wanted to see if there are differences in how our brains control the actual movements for speaking our first language versus our second language. They hypothesized that maybe our second language speech motor plans, the brain's instructions to our mouth, tongue, and throat, don't adapt and generalize as well as our first language ones, and if they don't generalize well, that could be a big reason why we keep that foreign accent. So, how did they test this? It is pretty clever. They used a technique called sensorimotor adaptation, which is basically training our brains to adjust to new sensory information. Imagine you put on special glasses that make the world look a little crooked. Your brain over time would start to adjust the signals it sends to your eyes and muscles to compensate. So things look normal again, even without the glasses. They did something similar with speech. They had people speak, and as they spoke, they slightly changed the sound of their own voice in real time. Specifically, they messed with the vowel sounds. Vowels have different formants, which are basically echoes of how we shape our mouth and throat. Think of the difference between saying E and A. Those are produced with different formant frequencies. The researchers subtly shifted these formants, making the individual's E sound more like an A, or vice versa. Now, here is the really cool part for bilinguals. They had people who spoke English as their first language and French as their second. They made sure that when these participants spoke English, the formant alteration was in one direction, and when they spoke French, it was in the opposite direction. This meant that to compensate for the altered sound in English, they had to adjust their speech movements in one way, and to compensate for the altered sound in French, they had to adjust their speech movements in the opposite way. The goal was to train the brain to develop different motor plans for English vowels and French vowels. And it worked. The study found that after this training, the participants were indeed producing different vowel sounds depending on whether they were speaking English or French. Their brains had learned to create specific motor plans for each language, adapting to the real-time sound changes. This showed they could build language-specific motor memories for speech. But the real question was, could these new language-specific motor skills be used in new situations? What happens when they say something slightly different? Not the exact sentences they practiced with. This is where the concept of generalization comes in. In motor learning, generalization means being able to use a skill you learned in one context, in a slightly different context. For example, if you learn to ride a bicycle, you can usually ride a different bicycle, or a scooter, because the core motor skills generalize. The researchers tested this by having participants produce different types of speech in English and French, things like parts of sentences or even just groups of words. They wanted to see if the adaptations they made to the vowel sounds in the practice sentences would carry over to these new speech contexts. And here is where the crucial difference emerged. In their first language, English, the motor plan adaptations transferred really well, even when they produced speech in a slightly different context, like just a part of a sentence. Their speech movements adjusted in the way they had learned. It was like the skill just naturally applied to the new situation. But in their second language, French, the story was different. The adaptations they had learned for French vowels didn't carry over as well to these new French speech contexts. It was like the motor plan was stuck in the specific situation where it was learned and couldn't easily adapt to a slightly different French. This drop in transfer in their second language was quite significant, meaning their brain was less flexible in applying those newly learned French speech movements. So, what does this all mean? It strongly suggests that the persistence of a foreign accent isn't just about our ears being tuned to our native language. It is also a motor issue. Our second language speech motor plans are more rigid. They don't generalize as broadly to new linguistic situations compared to our first language. It is like the brain says, okay, I learned this specific way to make this French sound in this sentence, but I am not sure how to apply it to that other French sentence. This limitation in flexibility, in how well the motor commands can be applied beyond the exact learning context, could be a major reason why we often don't achieve completely native-like pronunciation in a second language, no matter how much we practice. This finding challenges some existing ideas. Most current models of second language learning focus heavily on perceptual interference, how our first language interferes with our ability to hear and interpret sounds in a new language. While that's definitely part of the picture, this study highlights a significant motor component. It shows that even if we can perceive and adapt to L2 sounds correctly, our ability to apply those motor skills flexibly in different L2 contexts is limited. The researchers are careful to say it might be an L1 advantage rather than a pure L2 deficit. Generalization in motor learning, even for our first language, can sometimes be limited. However, the clear difference they observed between how well adaptations transferred in English versus French points to something special happening with L2 motor control. They suggest that prosody, the rhythm and intonation of speech, might play a key role in how well motor plans generalize. And perhaps this prosodic cueing mechanism just doesn't work as effectively for L2 speech. Of course, like any study, this one has limitations. They tested a specific group of English-French bilinguals in a Canadian setting. We don't know yet if these findings would hold up for people speaking other languages or in different cultural contexts. Also, the task involved reading sentences, and spontaneous speech is a bit different. It would be interesting to see if these motor constraints also apply when people are speaking more naturally and conversationally. But overall, this research gives us a powerful new perspective. It is not just about what we hear, but how our bodies, our muscles, and our brains work together to produce sounds, and how those skills transfer across languages. The finding that L2 speech motor plans generalize less effectively suggests a real motor constraint that can contribute to that persistent foreign accent. Even after years of effort, it is a reminder that mastering a new language is a complex feat involving not just our minds, but our entire vocal apparatus, and particularly the brain's ability to flexibly control it across different linguistic landscapes. What do you think of these findings? Does this resonate with your own language learning experiences? Let us know in the comments below, and if you found this breakdown helpful, please give this video a like, subscribe to RUBIN'S Mind Lab for more science explained, and hit that notification bell so you don't miss our next episode. Thanks for watching.